So let's crank through our next couple of problems. Let's say we have the set of equations 2 times x plus y plus 3 times z is equal to 10. That's the first equation. And then we have x minus 2y plus z is equal to 10. And then the third equation is negative 4x plus 3y plus 2 times z is equal to 5. First, let me just double check that I've written the system down correctly. 2x plus y plus 3z is 10, x minus 2y plus z is 10, negative 4x plus 3y plus 2z is 5. So each of those represents a plane in three-dimensional space. We've talked about that before. The intersection of those planes can manifest in a few ways. It could be a single point. That's all the cases we've had so far. It could also have no solution at all if the planes don't intersect, or it could have an infinite set of solutions if the planes intersect so that they all have a commonality of a line that exists between them. So we have three things we can do to these equations to get it into triangular form. We can rearrange the order of the equations. In other words, I could grab the second equation, I can move it up and make it the first equation. The order of the equations doesn't matter. I can also multiply an equation by any number I want, negative, positive, or fraction, as long as I do it to both sides of the equation. And then I can also add equations together. I can add the first one to the third one, the second one to the first one. I can add them in any order I want because we've talked about why that's legal in the last lesson. So what I'm trying to do here is get this equation to have 3 variables, this one have 2 variables, this one to have 1 variable. So the first thing you need to do is try to figure out this with this 2x. Can I multiply and add in such a way to kill this x right here? Can I multiply and add the equations in such a way to kill the negative 4x there? And the answer is yes in both cases. Let's see how you could do it. And by the way I'm doing these problems, the exact sequence of steps, there's a lot of different ways to do it. You might do it a different way. I'm showing you the way I did it. If you have a different way, as long as you're getting the same answer using the same technique, that's fine. Because I can see another way to do it right now. I'll save that for the end. All right, so what we want to do is figure out, firstly, we want to keep the first equation intact. So I'm not going to touch that one. I'm going to rewrite it. 2x plus y plus 3 times z is equal to 10. Now the second equation, I want to eliminate this x variable. So I'm going to go over here kind of onto the side and I'm going to write my little directions to myself. If I just add these equations, the 2x plus the x will give me 3x. That's not going to work. If I put a negative sign here, if I multiply this equation by negative 1, we're getting closer because it'll be 2 minus 1. But really we want 2 minus 2 to give me 0. I want to eliminate this guy here. So the way that you do this is you take row number 1, equation number 1, and then you add to it negative 2 times row 2. Okay, make sure you understand that. Remember, you can multiply any of these equations by a number that you want. So let's multiply the second one by negative 2. Why am I picking negative 2? Because then I'll have a negative 2x, and then I know when I add them together, it'll eliminate x. That's all I'm trying to accomplish. You have to know the goal, and you have to choose the path through the forest to get through the goal, to the goal. So you can multiply by any number you want. I can, of course, multiply that equation by 99, but it's not going to eliminate the variable when I add it to another equation. But if I multiply by negative 2, I'll have a negative 2x, and then I'm going to add it to this one and put the result in this location. That's why I'm writing it on this line. So then, when I do that, I'm going to take negative 2 times this, add it, it's going to give me a 0x. I'm going to take negative 2 times this, that'll give me a positive 4y. When I add it to this, will be a positive, I don't need the positive sign there, it's implied, 5y, because this will be positive 4 plus 1. If I take the negative 2 times this, it'll be negative 2z. When I add it to the 3, it'll be a positive 1z, because 3 plus a negative 2 right there. And then I have to do the same thing to the right-hand side. I'll multiply times this, I'll get a negative 20. When I add it to this, it'll be negative 10, because negative 20 plus 10 is negative 10. All I've done is multiply this by negative 2 and add it to the equation above. All right? Now we have to ask ourselves a similar question. How do we eliminate this variable? We just want to eliminate the x's first. Well, if I just add 2 plus the negative 4, that's not going to get me anywhere. But what if I multiply the first equation by 2? If I multiply the first equation by 2, that'll give me a 4x. And then if I add it to the negative 4x, that will eliminate the equation. So I can take the first equation times 2, and then I can add it to the third equation. The 2 times the first equation, I'll add it to the third equation. The result goes into the third slot here. That's why I'm writing this right here. So when I take 2 times this, it'll give me 4x. I'm going to add to this, that gives me 0. I'm going to take 2 times the first equation. That's going to give me 2y. 2y plus 3y is 5y. Then I'm going to take 2 times the this guy, which is going to give me 2 times 3 is 6. And then I'm going to add it to this. 6 plus 2 is 8. So it'll be 8z. And do the same thing here. 2 times 10 is 20. 20 plus 5 is 25. All right, so I have 5y plus 8z is 25. Okay, so you are not done, but what you have accomplished is you have eliminated the x variables from the bottom 2 equations. In order to get to triangular form, we want to get rid of the 5y. If we had it like this, it would be in triangular form. How do we get rid of the 5y? Well, the first equation that we have, we're going to leave unchanged. So let's just write that down. 2x plus y plus 3z is equal to 10. The second equation is perfectly great for triangular form, so we're going to leave it there. Plus z is negative 10. Now, how do we, what mathematical operation do we have to do in order to eliminate this? Well, if we add the 5's together, we're just going to get 10. But what we need to do is we need to multiply this equation by negative 1 and then add it to this one. So you could say negative 1 times the second equation plus the third equation. And the result of that goes in the third spot. So negative times equation number 2, negative 1 times equation 2, add it to this one. We're going to put the result right in there. So when we have negative 1 times the 5y, we get a negative 5y. We add it to this, it gives us 0. Negative 1 times z gives us negative z, negative 1z. Negative 1 plus 8 gives us a positive 7z, because you have negative 1 plus the 8. Negative 1 times 10 is 10, plus 25 is 35. So all we did was take a negative 1 times this, plus this, negative 1 times this, plus this, negative 1 times this, plus this, and we get our third equation. This is now in triangular form. All right, so in order to wrap up the solution to this, let me just copy the system of equations down over here so we can finish this. We have 2x plus y plus 3z is equal to 10. The second equation is 5y plus z is equal to negative 10. And the third equation is 7z is equal to 35. All right? So how do we solve the system of equations? Well, first, you take a look at the third equation. The 7z is 35, and you just divide. So you say z is 35 divided by 7, and so you get z is equal to 5. That's the answer that you get. And then once you get that answer, we stick it into the previous equation. So we're going to plug this in to the equation right above. 5y plus z is negative 10. Now we know what that is. So z is equal to 5, and then we have negative 10. So we have 5y is equal to, we subtract this over, so it's going to be negative 15. And then when we divide by 5, negative 15 divided by 5 is negative 3. So y is going to be equal to negative 3. So now we have y and z. So we take both of these guys that we have found and we plug it into the third equation, which is right above. 2x plus y plus 3 times z is equal to 10. Now, x is what we're solving for. Y is negative 3. Don't forget to wrap that in parentheses. 3 times z, where now we know z is 5, is equal to 10. So we have 2x minus 3. This gives us 15 equals 10. So we have 2x. Now, what is 15 minus 3? 15 minus 3 is 12. So we'll have 12 is equal to 10. Just double check myself. And then I'm going to subtract the 12 over here. So 10 minus 12 is going to give me a negative 2. And then when I divide by 2, I have negative 2 divided by positive, so I get a negative 1. Kind of botched that up here. We're going to negative 1 like this. So we have the x value, the y value, and the z value. So we have one solution to the intersection of these planes. The x value is negative 1, the y value is negative 3, and the z value is positive 5. That is the one solution. Negative 1, comma negative 3, comma 5. Of course, this is the x-coordinate, the y-coordinate, and the z-coordinate if you plot it in 3 dimensions. And if you were to graph those 3 planes, we've illustrated that before, they can intersect in such a way where there's only one point that's common to all 3 of them, and that's what you have. Now, I have one more problem in this lesson, but I want to talk a little bit more about this one. You know now how we have solved it. We started with what we were given and we just worked with it, and that's totally fine. But there are other ways in which you can do it. You see, what you want to check for is the top equation that you have, in this case had a 2x. You want to make sure that you can cancel with the x underneath it by multiplying and adding. In this case, we could multiply this by -2 and add it. Okay? You want to make sure that you can multiply by something and add it to this to cancel it. We multiply by 2, and then we added it to get rid of the 4. But if this number here in front of x were different, let's say this number were, 13, 13x minus 2y plus c. Well, then it would be a little bit more difficult, because how are you going to multiply 2 times something to get rid of the 13? You see, it was easy with numbers that are multiples of 2 like this, 1, 2, and 4. We can find numbers to cancel them. But if you start having weird numbers in there like 13 and 2 and 7, they're not really multiples of each other. Then you really can't get away from the idea of having to use a fraction. So if you had 13 here and you had to cancel the 13, then I might have to multiply the first equation not by a whole number. Maybe I multiply it by -13 halves. Because if I multiply this thing by -13 halves, the 2 will cancel with the 2 and the 13 halves, giving me a -13, which would then, when I add it, cancel to what's below. So you can always use these methods to eliminate and get rid of the variables, but sometimes you're going to have to use fractions to do it. And I have a problem later on to show you what I mean by that. The other thing is, remember the rules say I can multiply and add, no problem, but I can also rearrange the equation. So if I wanted to, I could take the second equation, I could make it the top equation, so it was now on top. That would be my equation that is left unchanged. Notice the top equation, I left it unchanged. And sometimes it's actually easier to do that, to move an equation to the top and make it your unchanged top equation, than it is to have to worry about a bunch of fractions. And so in this case, it didn't matter. I didn't have to move this to the top, because 1 and 2 and 4, I could eliminate things, no problem. But in the next problem, which we're going to do right now, we're going to find out that it's much to your advantage to maybe rearrange the ordering of these equations. So let's take a look at that. Sometimes in the beginning of a problem, it is very much worth your time to spend a minute to think about your game plan. And that is going to be evident right here. Let's take a look at this system of equations. 2x plus 3y plus, this is now an equal sign, equals 6 plus z. And then I have x minus 2y is equal to -1 minus z. And then the third one is 3x plus y is equal to -1 plus 3z. Let me double check my system. 2x plus 3y is 6 plus z. X minus 2y is -1 minus z. 3x plus y is -1 plus 3z. Okay, so the first thing you notice here is that this system is not set up like the other ones. In the previous ones, I gave you something x plus something y plus something z equals a number. But this case, some of the z variables are on the right-hand side. So a lot of times when a student sees a problem like this that's slightly different than what they've learned already, they start trying to invent math. They'll say, well, it's on the right-hand side, so let me try to eliminate that. Let me leave it over there, and I'll try to eliminate that. And maybe it works like that, and it works out, and sometimes maybe it doesn't. But what you need to do when you're confronted with something that's a little bit beyond what you've already seen, the easiest thing to do is just change that thing into something that you already have seen. So in other words, don't leave the z variables over there, move them all over here. So it's x and y and z equals a number, and then you have transformed it into something you know. So let's do that. The 2x is going to stay here. The 3y is going to stay here, but I have a z here. I can subtract it and make it -z on the left, and then on the right, I would just be left with the 6. All I did was subtract z from both sides. The second equation is x, and then I have a -2y. Here I have a -z. I'll have to add it to both sides. So I have a positive z, and on the right we'll be left with a -1. I just add z to both sides. Finally, I'll have a 3x plus y, and I have a 3z. Let me subtract the 3z on the left, and on the right I'll have that -1. I just subtract 3z from both sides. Now this set of equations looks exactly, or at least it's cast in the same form as everything we've already seen. Something times x plus something times y plus something times z equals a number. That's what you want. If you're given some weird randomization of things, put it all into the common form. If they also might give you something like x plus z plus y, z plus x plus, and then you need to rearrange it all into x and y and z, and then that's going to be the easiest way. So let's take a look at our game plan here. The problem with this set of equations is, if I leave it as is, then you're going to have to use a fraction somewhere. Let's think about how would we eliminate the 2 with the 1x. We want to eliminate the x and we want to eliminate the 3x for our first kind of step. So we can multiply this equation by -2. That'll give us -2x, and we can add, so we can eliminate that x variable. That works fine. Actually, it's the same thing we did in the last lesson, in the last problem. But how are we going to eliminate this 3? I can't really multiply something up here by a whole number to give me 3, and I can't multiply the 3 by a whole number to give me a 2. So there's nothing I can pick to multiply those equations, and you might think, well, I'll just use this equation. And you want to get, I shouldn't say that you can never do things, but what ends up happening is when you deviate from what I'm teaching you here, it might work out sometimes, and you also might get confused sometimes. So I'm trying to tell you the most bulletproof way of doing things. Yes, you are allowed to do that, but if you've eliminated this x from this equation in step number 2, then it may not be obvious that you can eliminate this guy here. So the question is, there's 2 ways, or the answer is, there's 2 real ways to eliminate the 3 using this equation here. Okay? The first way is to multiply this equation by -3/2, a fraction. If you multiply by -3/2, then across the whole thing, you're going to get the 2's that are canceling, 3/2 and 2's. The 2's are going to go out, and you'll have a -3x, and you'll add it with this guy. The problem is, you're going to have to multiply that -3/2 to everything, and you'll have fractions everywhere, and you'll have to add them all here, and so you'll have fractions everywhere, which is fine. You can do the fraction arithmetic, but it increases your pain level. So it's to your advantage to have the first equation on the top, the one that you leave unchanged, to just be a plain old x variable. Because if I leave this if I move this equation up to the top so that this first variable is x, then I can eliminate anything else underneath it because the coefficient is just 1. I can multiply by anything I want to cancel anything I want. So this will be the first problem where we actually introduce a swap. What I'm going to do is we're going to take the second equation and make it the first equation. X minus 2y plus z is equal to -1. The next equation I'm going to write down is 2x plus 3y minus z is equal to 6. The third equation is 3x plus y minus 3z is equal to -1. This system of equations is much easier to deal with, but it's actually the same system of equations. The order that you write the equations on the board or in your paper doesn't matter, but this one's easier to do because I can take this equation, multiply by -2, and add it to this one. That will cancel the 2. I can take this equation, multiply by -3, and add it to this one, killing that 3. So just by moving an equation up there, especially if that first variable is like a 1 or something very low, then I can use it to kill anything and cancel anything underneath it without having to deal with all the fractions. So in this step, since we did a swapping here, I'm going to write down in my little notes what I did. I'm going to draw a little arrow. You can see it written in different books, different ways. But the way I write it is row 1 has been swapped with row number 2. The double arrow means I've switched positions. So the previous row 2 has been swapped with the previous row 1, and then the result of which goes into this line right here. All right, with that out of the way, we just solve the system of equations the same way as we've done before. The first line we keep the same. X minus 2y plus z is equal to -1. And then the second line, we have to decide what to do. Let's multiply by -2 and add. So over here in the margin, we'll multiply, let me just double check myself, -2 times equation number 1, and we'll add that to equation number 2. -2 times this is -2x. We add that, we get 0. -2 times this will be +4. +4 plus this will give us 7y. -2 times this will be -2z, plus this will be -3z. -2 times this will be +2, don't forget the +2, plus this will be 8. So I'll get 7y minus 3z is 8. Okay? How do I eliminate the 3x? Let's multiply the first equation by -3 and add. So we will say -3 times row number 1 plus row number 3. And then we will say -3 times this equation, will give us negative 3x. We add that, we get 0. Negative 3 times this will give us positive 6. Negative times negative is positive. Positive 6 plus, we're adding to this equation, 6 plus 1 is 7. So we have 7y. Negative 3 times this equation is negative 3z plus this will give us negative 6z. And then negative 3 times this guy right here is going to give us negative 18. Negative 18 minus 1 is negative 19. You know, I could erase this and make it beautiful and edit it out, but I need to show you sometimes I make mistakes too. And what you have to do is always be checking yourself. You see, I made a mistake here. When I started doing the multiplication, I got sloppy. I said, well, this times this, add to this, but that's not what we're doing. We're multiplying the negative 3 times these numbers. So it's not negative 19 right here. It's negative 3 times this will give me positive 3 plus this will give me a 2. So the third equation is 7y minus 6z plus 2. Negative 3 times this is negative 3, add to give me 0. Negative 3 times this is 6, plus 1 is 7. Negative 3 times this is negative 3, plus a negative 3 is negative 6. Negative 3 times this is 3, positive 3, minus the 1 gives us the 2. So this is our next set of equations. Now I'd really like to finish this on this board, so let's squeeze it in right below. We want to eliminate the 7y from here, and I think you can kind of see how to do that. The first equation remains unchanged. 2y plus z is equal to negative 1. Second equation remains unchanged. 7y minus 3z is equal to 8. But I need to put some notes about how I'm going to cancel the third equation, or the third variable here, the 7y. Let's multiply this equation by negative 1. That'll give me negative 7. I'll add to this guy. So my notes will be negative 1 multiplied by row number 2, and I'll add that to row number 3, and the result will go into row number 3. So when I take negative 1 times the negative 7y and add it, I'll get a 0 down here. When I take negative 1 times this, I'll get a positive 3. Positive 3 minus the 6z will give negative 3z. Okay? And then the negative 1 times 8 is negative 8, plus the 2 is negative 6. Okay? So the third equation I have is negative 3z is equal to negative 6. So what I want to do now is take this system of equations. This is in triangular form. 3 variables, 2 variables, 1 variable. Let's copy this system over just as it sits. No changes to it or anything. We'll just copy it over on the next board. What we have, or what we've left with, is x minus 2y plus z is equal to negative 1. Then we have 7y minus 3z is equal to 8. Then we have negative 3z is equal to negative 6. Let me double check. X minus 2i is plus z is 1, 7y minus 3z is 8, and negative 3z is equal to negative 6. I have made no changes between this and what we wrote here. I've made no changes at all. I just copied it over again. So then we take our third equation and we say, all right, we're going to say negative 3z is equal to negative 6. So we divide by negative 3, we'll get a positive 2. So that's what z is equal to. And then I will take this value of z and I'm going to plug it in to the equation right above, which is 7y minus 3z is 8. 7y minus 3, z is now 2, is equal to 8. 7y minus 6 is equal to 8. 7y, I add 6 to both sides, so 8 plus 6 is 14. And I divide by 7. Y is equal to 2. So now I have I have y and I have z. And so I take this value of y with this value of z that I have calculated. Let me just catch up to myself. And I stick it into this third equation here, which is x minus 2y plus z is equal to negative 1. X minus 2 times y, which is 2, plus z, which is also 2, is equal to negative 1. X minus 4 plus 2 is negative 1. X, this becomes negative 2, negative 1. Now I'm going to add the 2 to both sides. Negative 1 plus 2 is going to give me a positive 1. So I get an answer of 1. So I have the x and the y and the z value. That means there's one solution, which is a point. The x value is 1. The y value is 2. The z value is 2. So that's a point in space, the intersection point of those planes, 1, 2, 2. Of course, this is the x variable, the y variable, the z variable, as always. Now, I want to make sure you understand what we did. I mean, we did basically follow the same set of rules that we've always been using to solve these problems. The main difference is that the equations that I gave you in the beginning had variables on the other side. If that ever happens, just pull them over to the side. Now, you can solve the system just using this guy. You can eliminate with this variable, if you want, by multiplying this equation by -2 and then adding it. That'll work. This is going to be harder because I can't multiply 2 by anything or 3 by anything to get rid of it. So instead of dealing with the fractions, which is what I would have to do, I take this equation, I move it to the top like this. I can swap equations. Now because I have a very low coefficient here, it allows me to cancel these very, very easily. And so I always ask you when you're doing these problems, just check the coefficients of x and make sure you're going to be able to eliminate all of the variables below before you get started. It would really be terrible for you to eliminate this guy, or let's say eliminate this one, and then when you try to do the third one, you realize you have to do all these fractions because you didn't look ahead. So just get a game plan and see if you can eliminate them, and if you can rearrange the equations to make it easier, then just do that first. So make sure you can solve these. So far, all of these problems have been solutions at a given, just a point. Right now, in the next lesson, we're going to be getting into some cases when we solve the system of equations and the solutions are not really a single point. They end up being either no solution or infinite number of solutions along a line or something like that. So make sure you can solve all of these proficiently, do them yourself, and then follow me on to the next lesson, and we will continue learning how to solve these linear systems of equations with 3 variables. Learn anything at mathandscience.com.